record on this. All right. So let's start the way we always do with a look at the schedule. Today is March 28th, my 20th year anniversary with LSU. Next week, we have 2 review classes scheduled. Review, and then we have an exam on the 11th of April. Well, that's not really next week. That's like there's a break in between there. So my plan is to give you a quiz on the 7th. Now, I know I normally don't announce quizzes, but this time, I'm just sort of helping you out. I'm going to give you a quiz on the 11th. Yay. Of April. 7th, sorry. 7th. I meant to say the 7th. We get a test on the 11th. Yes. All right. So as I said, our goal is to get at least 12 quizzes. And we've got 8. So got at least 4 more to go, I'm hoping. It's usually hard to squeeze in more than 12, but you know, one can always be hopeful. Okay, so I thought I would start. I was going to go over the quiz. So here's quiz 8. And I figured that this is something that you needed to go over. So let's look at Mikey. I put a care-at method on this class just to avoid index out of bounds exception issues, right? And then so you just didn't have to think about them. And then I have an equals method, and the equals method is going to check that the name, this name equals that name, where the name is stored, you know, inside the my key class. And as is good practice, it's final. Okay, and so now what I'm going to do is I'm going to create an array of my keys, and I'm going to have fab, baf, fubba, buffa, and abf, right? Okay. So now what I'm going to do is I'm going to sort them, and then I'm going to print out the first thing in the list. Now, let's look at how this sorts. How does it work? How does the compare to method work? The compare to method first looks at character 1, and then looks at character 0. Okay. So it's going to look at character 1 first. And so if this character 1 is less than that character 1, it will sort on that. So we want to have the A in the second place. You see that? The middle character should be the A. And then I'm going to sort on character 0 next. So the next character, so in the next character should be the B. So it should have AB in it, right? Does that make sense? I'm sorry. Yes, it should have A in the middle and B in the front. That's what I meant to say. Yes, sorry, I switched it around. BAF, right? See what I'm saying? Starting first on the second character, and then on the first character. So it should be BAF. And we can always do the following. And it prints out BAF. Now, you know, one of the things I do with these quizzes, of course, is I have the system automatically compile and run them and verify the answer. So I know I don't make typos and kill myself with it. All right, so BAF, it was the answer. And you should see how it came about, right? The idea, what I'm trying to get you to do here is look at the logic of the compare to method and understand how it works, right? Any questions on that? All right, good. Okay, now I have one of these kind of tests, and these are sort of standard things that you've seen multiple times before, right? It's a sort of a standard sort of control flow with exceptions problem. And so what happens with line 0? Does line 0 execute? The label with line 0. So the / line 0, that line. Does it? What happens when I access element 2 of an right? So what happens here? I'm trying to remember your name. Shoot, I can't do it. Bennett. Okay. Right. There's 2 B's. There's a Bennett and then there's a Bo. And Bo doesn't seem to be here. Okay. All right. All right. So yeah, it throws an index out of bounds exception, array index out of bounds exception on line 0. So what about line 1? Does it execute? Does it execute? No. Because when you have once you have an exception, you cease executing, right? So it jumps out of the routine at this point. Okay, so line 2, does it execute? Yes. Line 3, does it execute? No. 4. No. 5. No. Catch exception, does it execute? Yes, it does, because array index out of bounds exception is a subclass of exception. Finally, does that execute? Yes, because finally always executes. What about line 8? No. No. Oh, I'm sorry. Yes, you're right. You're right. Because we did handle the exception. I'm sorry. We did handle the exception. So yes. If we had not handled the exception, it wouldn't have executed. But yes, it does execute. Sorry. All right. So you can sort of just see these answers there. We talked about adding to a priority queue, and we said that was order log n, as well as removing from a priority queue. We talked about, but the other prepend C. Oh, that's a typo. I didn't see that. So when we do a random access of an element in an array list, right? That's just a get, a square bracket, and that's order 1, right? Because how does the compiler implement that? It gets the address of the start of the array. It adds a number to that equal to the offset to get to where we want, and then it looks up the value there from the machine directly. So that's order 1. On random access on the linked list, however, what do we have to do? If we want to get the nth element of a linked list, we have to start at the beginning, and we have to walk one by one until we get to that number. So it's order n, right? And hopefully you don't need to memorize this like you're a doctor learning what medicine goes with what disease, right? Hopefully it makes sense. If you understand how an array works and how a linked list works, this will just make sense to you. Similar thing for the prepend operation. So the prepend on the linked list operation is what? We take the next pointer, we create a new node, we take the next pointer on the node, point it to the current head, and then remap the head to the current pointer. That's like 2 instructions, and we're done. So a prepend operation on the linked list is order 1. On an array, though, if I want to prepend to an array, I have to move everything over by 1, which is order n operation. Make sense? hopefully, if you understand the algorithms and things that we've assigned orders to, you can understand why they have the orders that they do, with the possible exception of priority queue. Okay, any questions about any of that? Yes, Vanik.
So logically, I understand like order n because you're going to each element.
Right.
But what about log n?
No, as I said, priority queue you have to memorize.
Oh yeah.
That one you have to memorize because we haven't talked about how that works. That's a heap sort. And I mean, I think I shouldn't try to teach you everything in computer science. I should leave that some of it for another class. You know, if you were all getting A's and I never had to curve a quiz or an exam, then I'd probably cover heap sort. But otherwise, I just don't want to, like, you know, overload. Okay. Any other questions? All right. You remember we talked about this Fibonacci iterator? Wasn't that fun? Remembered how that worked? Excuse me. And then we talked about, what was it? Yeah, FibMap. I didn't get to finish what I wanted to say with FibMap. So what we did with FibMap, right, is we came up with the notion of caching. We came up with the idea that, you know, sometimes if we have this expensive operation to call, and we're using Fibonacci as a proxy for that, right? We have an expensive operation to call, and we want to not always pay the cost, especially if we're calling with the same value. One of the things we can do is cache the result. And so what we did is we cached the last thing here. And if we use the cache, right, then we did a print statement just to, we did a print statement if we didn't use the cache, it looks like. So we had this notion of last n, and we updated that. And we used a Boolean to figure out whether we wanted, you know, whether we were at the top level of our chain and so on. But suppose I did this. Suppose on this bottom line, rather than just using, you know, one value all the time, I use two values, right? No suitable method found for println. Oh, well, of course. I get the print statement in Java and Python confused sometimes. All right. Now this time, I can't ever use the cache because every other time I'm calling a different number. And so I'm never using that optimization that I made, right? So could I make a more general optimization that will work with more values than just one repeated value? Anybody have any ideas? Anybody need more coffee? Yeah, you need more coffee. Okay. I want a suggestion. What should I do? You have brains. How can if I want to save more than one value, what can I do? An array is one possibility. The difficulty with an array, now an array would work for a Fibonacci number because a Fibonacci number is probably going to be, you know, something in the range 0 to 100. So I could use an array. I could, in fact, I could do, let's make a copy. So what I could do is I could say new int cash equal new int and say 100, right? And then I could say if what would be my test? How do I know whether to go look it up in the array or not? Come on, people, you can do this. So the idea is we're going to use an array to cache the values that we've previously computed with Fibonacci.
Right.
The question is, how do I need to put an if statement here. So last time I compared with a variable called last n that I created. How should I know whether to use the value from the array or not? Vanik. Well, okay, so the array length is guaranteed to be 100, right? Yeah. Gesundheit. It's one of our German words, like kindergarten and Schadenfreude. Fahrenheit. So what should I do? How should I know whether to look up the value? Should I just unconditionally return the cache? Should I say return cache n? Should I do that? Does that look like a good idea? Bennett, what do you think we should do? Well, okay, so here's what I'm thinking. All right, so I hear what you're saying, and the way I was imagining this would work is I would store the 5th Fibonacci at index 5 and the 10th Fibonacci at index 10. So I wouldn't have to go through the array. I know which one, right? The question is it okay to just do this? What am I going to get if I do this? If I just return that right there, what am I going to get? What's going to be in cache at position n when I call this? What value? Okay, let me just run it. Since nobody knows. Oh, and I got to change the name. That's actually surprising me. I gotta understand that. Hold on. Oh, duh. I didn't switch to the new class. Zero. Oh. Is that what you expected? So whenever you instantiate a new array, of integers, by default, it's filled with zeros. And I never put anything else in the array. So what did I have? Right. So what should I do there on line 7? Obviously, unconditionally returning cache n is the wrong thing. What should I do? How do I know if there's a valid value there? Excellent. Yes, that's what I've been trying to get somebody to say. JJ said it. If cache n not equal 0, return cache. Okay, so what's the problem now? Right? What problem do I still have? Well, this is only going to print it out if it winds up needing to compute it, is the idea. So it's only going to print it out if it winds up needing to compute it. What's going to happen now if I run it now? What, Bennett? What do you mean by nothing? I'm never actually changing cache n. Where should I do that? So it's, if I want to use cache n, if I want it to have values, I've got to put them in at some point, right? And where should I do that? Where did I put them in the last time? You got an idea, Vanek? No. Where did I put it in the last time? Where did I store a value when I was just caching a single value? Do you see it? Yes. What's your name? Roy. Yes, where those comments are, right? So what if I go to where those comments are? Cache n equal r, right? What if I do that? And now look at that. I only calculate those two values, each of those values once. And then the rest of the time it comes from the cache because it doesn't print them again, right? So what I've done is I've taken an expensive calculation and I figured out sort of automatically when I don't need to recompute it. Now, Fibonacci is kind of special because, you know, if I take a number, probably even before I get to 100, it gets to a negative value. I can't remember when it does. It gets to a negative value. And so there's only sort of a nice bounded set that fits in, like, say, 100 values that I need to cache. But let's pretend that's not the case. Let's pretend that I can easily calculate the Fibonacci number of 24, billion, right? I'm not going to create an array of size 24 billion to hold this, right? That doesn't make sense to do that. I should stay right near my microphone. It doesn't make sense to make an array of 24 billion. So what's another way that I can accomplish the same thing as I did with with the array? What could I use instead of an array? Vanek. I could use an array list, but it's going to have the same problem, right? It's still going to grow. If I just want to store element 25 billion and 3, then I have to allocate that entire span of numbers, right? I'm trying to optimize my memory a little bit here, right? I don't want to allocate an array of size 25 billion. Chris, are you raising your hand? I didn't think so, but I was hoping. A hash. Yes. How about that? Let's try that. So what we could do instead of using cache up here, map, integer, cache equal new hash map. Now I need to import that. I'll just import Java util star. Instead of importing both map and hash map, I can just do that. And now, how should I change that line? And obviously that works with arrays, but not with maps. How do I do that? How do I know if a value is in the map? Chris. I could get the keys, and then I could check to see if it's in there. But there is a way I can directly ask the map if the key is there. How can I do that? So I had a word count program. Anybody remember that one? Maybe somebody should look at it. How did I know? So when I had the word count program, I needed to find out if the word was already in my map before I incremented the count for it. Now, if it isn't in the map, then I needed to put a 1 in. How did I know whether the value was in the map? There's lots of people with computers. You guys can figure it out. Look at my word count program. How did I do it? Yes. Yes, what's your name? Simeon. Okay. It's a biblical name, right? Who, can't remember who was, well, anyway. So I'm going to say if cache dot contains key n, return cache dot get n, right? Look at that. Okay, now I need to change this, right? What should that look like? Who can tell me? Bennett. It's cache.put. Yeah, okay. I'll just leave this other one here so you can see it. Ta-da! It works. So this is something that you can do with maps, right? You can store values that you've previously computed or that are a lot of work to compute, right? In this case, it's a map of an integer to an integer. I mean, the other, the more obvious thing is something like a word count I did, but there's lots of uses for maps. And if you continue in computer science, you will use them all the time. If you want to think about it this way, a map is like a generalization of an array. It's slower than an array, but it's potentially less memory intensive than an array. And the other nice thing about it is it works with other types. So an array is like a map that can only work with integers as keys, right? Whereas a map is more general. I can take any unmodifiable data type that has either a compares to or an equals plus hash code and use that as a key. Make sense? If you understand maps, then you can say achievement unlocked. I'm sorry. So I'm just saying that a map is like a generalization of an array. Okay, an array is like a map where you can only use an integer as a key, right? And and if you want to use an array, right, it's not going to allow you to have keys that are negative. So it's a positive or integer or zero. A non-negative integer is what you must use as your key. And you must allocate all the space for the numbers that you're using. Those are the limitations of an array. But if your application fits those limitations, that's the fastest and best way. But many things don't fit that, right? In this case, Fibonacci kind of does fit that, but the other way that you can do it is with a map. I can take an integer to an integer. And if I do it this way, right, then I don't have to allocate space for all the things that are in between, say, 25 billion and 0, if those are the two values I care about. I can just allocate those two values, right? And the map and the internal logic of the map will make it all work. Does that make sense? All right. Any questions about that? So the rest of you who are being silent and not participating, this is not a key to success. Just letting you know. The key to success is to understand things and be able to figure them out on the fly. And having me here to help talk you through it can make it a little easier. But trying to engage more is better. Okay. One of these days, this cough will be done. All right. Let's go back to my linked list. How am I doing on time? I'm doing great. Okay, so let's look at my linked list. And we talked through this code. And you remember how it works, right? I have this next, and I have this head and this tail. Is this the same code I used in my slides? Yeah, it is. There it is. Yeah, and it has this insert method. You remember how all this worked? And if I tested you on it, you'd all get 100%? See, it's always when everybody says they understand stuff. And then when I ask that second question, somehow or other, the answer is different. It really ought to be the same. And if there is a difference between those two answers, then you should ask me a question. If you can, Anyway, so what I thought we would do, we have this linked list. And suppose I want to turn it into, so suppose I wrote this linked list. Suppose I want to use it as a stack. I want to push in a pop method, right? How do I make a stack? Now, my first thing, let's see, this is a list of its objects. Okay, so I'll just put them at the top. Stack methods. So public object pop, and then I'm going to do something, and I have public void push, and I'm going to do something. Okay. Now I may already have methods that do the things I want. The question is, what are they and how do I do them? Okay, so keep this in your mind. I want to push and a pop, and I want to stack. And when you think of a stack, right, you should think of a stack of books, right? So whatever thing I put on the top last is the thing I take off first. So last in, first out. LIFO. Okay, so that's what a stack is like. So let's go down the list and see if we've got something that implements a push or a pop. Okay, so I've got the static, I've got the link class itself, I've got head, tail, size, I've got a constructor. I have a get method. I have a set method. I have a clear. I have an insert. Stop me when I get to something that you think you can use. I have add. I have compute size. I have size. I have prepend. Nobody saw anything they could use to make a push or a pop method?
Pop is taking something from the front. Or is it back?
Well, it doesn't matter really whether it's the front or the back. The thing I want from a stack is LIFO. I want the last thing I put in to be the first thing I take out. It could be. So I could add at the tail. I could add at the tail and remove from the tail and get that. Or I could add at the head and remove from the head and get that. Either way, right? The question is just pick something. What do you want to do? How do you want to make a push or a pop method? So, right. So how do I put something at the end with this? What was the method for that? What did I make? Add. Right. Okay. So add. So what I'll do for my push method, I'll just call add. Right. Done. Now I need to take something off the tail. Now I don't know that I've actually made a method for this. Yeah, I have an iterator remove, which isn't what we want. Yeah, I don't have any kind of remove method in here. So I guess we have to make that ourselves. How am I going to make a pop method? How do I take something off the tail of my list?
Well, if you're taking the tail out to a separate value, so then put something else in the tail.
Right. I need to change the value of the tail. So how am I going to change the value of the tail? What do I need? What do I need to put in the tail instead of what's currently there? Right. And how do I get that? How do I get the value before the tail on a linked list? Bannock, how? Well, .prev is on the doubly linked list. This is a singly linked list. We don't have a .prev. .prev would be a great solution. So if I wanted to implement a stack with a push and a pop on it and put it from the end, I could do that right here with a prev. But since I don't have that, yes, Chris. Well, I can iterate from the head only, right? But I can iterate from the head. So what I can do, right? Yeah. So I can say link X equal head while X what? What's my test? What's my test? How do I know when I'm at the right spot? Yeah, less than isn't something I can do, right? Right. What's your name? Brandon. While x dot next. Thank you, Brandon. Not equal tail. What do I put inside? It's the right. Yes, Bennett. Yes. Right. I can do that. And now at the end of this loop, I should have the X I want right, I should be able to say, so the value that I want to return is what? It's what's at the tail, right? So I'm going to have to do this. I'm going to have to say link return. Well, can't use that as a keyword. Link ret equals tail. Then I'm going to say tail equals X, and then return ret dot data, right? Are we good to go? What could go wrong? Let me ask you this. What happens if the list is empty and I call pop? It's not going to work out too well, is it? So what should I do if, so how can, yes, Chris. Well, I could do that, but if the list is empty, if the list is empty, what is going to be null? What things are going to be null? Head and tail would be null. So I could just test, right? I could say if head is equal to null, right? If head equal null. Now I have to decide at this point, do I want to throw an exception, or do I just want to return a null? I'm just going to return a null. Let's ask ourselves another question. Suppose our linked list has exactly one thing in it. When I pop it, right, the list is empty. And when it's empty, head and tail should be null. Am I going to do that with this code? I am not assigning the head in this code. So it will not happen, right? So another special case, in addition to empty list, another special case is the list has one thing in it. Then head and tail would be equal. So I can say if head equal tail, right? Then I can say link ret equal head. I can say head equal tail equal null, return ret dot object, right? Or data, sorry, not object. And so I've made a push and a pop method. Now, we talked before about whether to push and pop from the back of the list or from the front of the list. Now we did it from the back of the list. I'd like to think about what happens if we do it from the front of the list. So public object pop. Public void push object. And on my push method, yeah, okay. So I think this logic up here, this is fairly generic, right? That's going to be the same whether I'm pushing or popping from the front to the back. This is testing if I have one thing or zero things in my list. So I'm only really concerned about two or more. So if I want to do two or more, what do I do in terms of push and pop? Did you see a method on here that could help you in any way? Yes, Chris. What? Prepend. Yes, there's a prepend. So I can just call that prepend. Now, if I want to pop a method from the head of the stack, how do I do that? If I want to pop if I want to pop something from the head of the stack, if I want to pop from the head, if I want to implement my pop by taking from the head of the list,
So wouldn't it just, do the same thing you, link red equal and turn head into
not x dot next, head equals what? Most happens. Not, we don't have an x at the moment. What? Who's speaking? Oh, Chris, ret dot next. Yes, we could use ret dot next. I was thinking head dot next, but since ret and head are equal, it's just as good. Head equals ret dot next. And now return ret dot data. Look at that. So which way do you, which end of this of the linked list do you want to push and pop from? The head or the tail? You don't know? What? Yeah, but I could, it's push and pop whether it's the head or the tail, as long as I'm pushing and popping on the same end, it's going to be a stack. The question is, which of these implementations do you think is better? We've got this one from the head, and we've got this one from the tail. What's different about them? The head is shorter and it's simpler. And what doesn't it have that the tail one has? It has a while, yeah, the tail one has a while loop. So in order to pop from the tail, I have an order n operation, right? Because I have to go through every element in the list to do it, because I have to find that next to last thing. But if I'm doing the head, right, I don't have any while loop. It's an order one operation. So if I'm pushing and popping from the head, it's much faster. And so if I have a singly linked list, that's what I should do. Okay? If I have a doubly linked list, I could just use .prev and it doesn't matter. But if I'm using a singly linked list, then it does matter. And a singly linked list saves a little memory, right? I don't have to have a prev. It saves complexity because I don't have to make sure that prev is always doing the right thing, right? So there's an advantage to that. All right. I guess that's where we stop today. I had a question I didn't see. Can you run through how the character comparison works again? Oh, well, I'm sorry about that.